All right. Well, first of all, thank you very much for showing up at the last time slot of the day. I mean, it shows true dedication, so I really appreciate that. That doesn't make me feel so alone here, so perfect. I'm going to talk about reliable agentic systems need durable execution. So yeah, let's look what that means. Let me start my timer. And by the way, everything I'm doing is straight in Visual Studio. My slides are based on Markdown. Everything is scripted, what I'm running. It's all thanks to a very nice VS Code extension called Demo Time by Elio Struijf, another Microsoft MVP. If you're into presenting and doing stuff, then definitely check out the Demo Time. It's really a super cool VS Code automation tool, I would say. It's not just a presenter tool, but it's really like a very cool automation tool. So I'm Marc Duiker. I'm a developer advocate at Diagrid. That's a company founded by the co-creators of Dapr open source, and yeah, that is the main topic of today, Dapr. I'm also one of the Dapr community managers, Microsoft MVP, and I have a lot of like creative hobbies. A lot of them involve like pixel art, so there's some pixel art sprinkled throughout these sessions. I saw that the previous presenter used VS Code pads. It's another extension in VS Code. I also contributed a lot of the VS Code pads for that extension. Feel free to check out marcduiker.dev if you want to see more pixel art or creative coding stuff or some music stuff. There are some interactive elements to the session, and I'm using Engage Time for that. Again, that's also created by the same guy that created Demo Time. So please scan this QR code. You can ask questions asynchronously there. Yeah, you can react to this content with emojis. You can participate in 2 polls that I'll show later. More importantly, you can actually access the resources that I'll be sharing at the end, and you can also give me feedback, which I would really appreciate. So please scan this. When there's time for the polls, I will show this again. So if you didn't catch it now, I'll share with you later. So just a warning, so this session is not about yet another agent framework. This is more about using existing tools and patterns and concepts to build reliable agentic systems. So you still remain in your seats, so that's good. Right, so let's make sure that we all understand what I mean when we talk about agentic systems. So for me, an agentic system means that they use LLMs to make decisions and take actions. So, and they always have like a couple of key components. So there's like reasoning and planning involved that you instruct these LLMs to do. There's some memory involved. There's some state stores, some tools that you can use, and some orchestration, right? Because you need to coordinate multiple steps. So there are some workflow elements in there. So everyone and their own goal is like building agent frameworks these days, right? So of course, Microsoft has a Microsoft Agentic framework. There's OpenAI agents, there's LangGraph, CrewAI, and of course I have to list Dapr agents because that's part of the Dapr project, and I'm usually promoting anything related to Dapr. So if you're a Python developer and you want to use an agent framework, have a look at Dapr agents. But again, that's not the topic of today, right? I mean, if you want to use like new shiny toys, please go ahead. But the question is, do you really need an agent framework to build agentic systems? And I don't think you need to. I think we have a lot of tools and things already that we can use to build these type of systems. So what you need to realize, and I think probably you know, that agentic systems are typically distributed applications. They are distributed systems, so they involve like communication between different services, in this case LLMs or agents, and they communicate either synchronously or asynchronously via message brokers, and they need to store their data in data stores. So there's not that much new things going on. Of course, they have some specifics, but the familiar challenges from the distributed systems are also problems with agentic systems. And we've been dealing with those type of systems for decades, really. So we can actually reuse a lot of the tools that we know. All right, so the first thing that I want to cover is like durable execution. Maybe you haven't heard of the term, but you probably definitely know some tools. So what is durable execution? So that enables code to run to completion, even if the process that runs the code fails. A new process will be started, and it will pick up the code execution where it left off. And it's all made possible because the state is automatically persisted in a state store. There's a replay mechanism, and that state will be rehydrated from the state store, and then your code will continue to run. So it's super powerful, and it's being used by a lot of workflow engines. So why is it important for AI agents? Well, for instance, you can resume from your last checkpoint instead of rerunning your whole workflow and executing all these LLM calls again. So you can save some cost there and also some latency. There's very predictable behavior when you use gerbil execution, when you use these workflow engines, and they typically have like built-in resiliency and built-in observability, which is of course things you really like. Which brings us to Dapr. And before I explain what Dapr is, I first want to know what you think that Dapr is, or how familiar are you with Dapr? So again, you can use the QR code or the web page that you probably already have opened. If not, you can scan this QR code again. I ask this question at every conference, every session that I give, and there's always like a very big variation. Some people are completely new to Dapr. Some people have heard about it, but never used it. And some people are running it in production. So this is like a good data point for me to capture over the years. So, and sometimes people think it's the ORM from Stack Overflow, but as far as I see, no one is voting for it yet, so okay. Some people completely new, okay. Some people have heard of it but never used it, and one is using it in production, okay. Well, who's using it in production? Okay. Thank you, Alex. All right. I know everyone by name who is using it in production, so cool. All right. Okay, good to know. Thank you. So Dapr is the Distributed Application Runtime. It's a project that's about 6 years old now and is specifically designed to help developers build distributed applications. It's part of the Cloud Native Computing Foundation. It's a graduated project since last November, which means it's a very mature project. A lot of big enterprises depend on it. And basically it offers all kinds of APIs to build microservices and these days also agentic AI systems. So I'll do like a very quick explainer about Dapr. So Dapr runs as a sidecar, as a separate process next to your application. So you can basically use any language as long as you can communicate over HTTP or gRPC with this sidecar. And Dapr exposes a lot of APIs that you can use in your application. So if you want to do like async messaging, or you want to do save some state, there's also like a built-in actor model. So it offers a lot of APIs that makes it really easy to build microservices or agentic AI. In this talk, however, I will only focus on the workflow because there's a built-in workflow engine in the sidecar, and the Conversation API, which is a relatively new API, but it's like an abstraction over different LLMs. The nice thing about Dapr in general is that it decouples your application layer from your infrastructure layer. And I'll give an example about that later, but it makes it really, really flexible to use. Okay, next up, workflow engines. And again, I have a poll for you if you are using or ever have used a workflow engine. So I've used, like, for instance, Azure Drupal Functions quite a while before I started using Dapr. I've used Dapr Workflow. There's also like a very old one which is still used also by Microsoft. I'm not sure if it's in the list still. Oh yeah, BizTalk in it, yeah. Yeah, I think BizTalk is still running. I mean, it's like 20 years old or something. That's amazing. Temporal is quite a well-known one. I think it's not so much a big thing in the .NET world. I think it's mostly Java, I think. But I think it has a .NET client. Yes, something else. Okay, who's using something else as a workflow?
Custom solution on top of Akka.
Ah, okay, yeah. I think a lot of organizations have like a custom solutions for these kind of things. So yeah, but thanks for sharing. Nice. All right, and for a lot of people, they've never used it. Okay, that's also good to know. Thank you. So Dapr has a built-in workflow engine in the sidecar, and it's inspired by the Drupal task framework. So if you're familiar with Azure Drupal Functions, then you know what the Drupal task framework is. It's used in many places in Azure. You write your workflows in code, so you can use .NET, but also Java, Python, JavaScript. And these workflows are stateful. They're persisted to the state store, and the workflows should be deterministic. And it's between brackets, should be, because it's up to you, the developer, if they actually are deterministic. It depends what kind of code you write in these workflows, but they should be deterministic. The smallest building blocks of these workflows are activities, and inside these activities you can use any code, what you like. So those can be like non-deterministic code. So it typically means you call out to another service. In this case, you call out to an LLM provider, or you save some state in a data store, etc. So just some small examples on how it looks like when you use Dapr Workflow before I show the code, which is a bit more involved. So if you want to start a workflow, here's like a post endpoint that uses the Dapr Workflow client, and that has a method called schedule new workflow async. You pass in the name of the workflow and the input, and what you get back is not the result of the workflow, but you get back an instance ID. So for every workflow you start, you get back a unique ID for running that workflow, and that's because workflows are completely asynchronous, right? They can be running for days or weeks or months or years or even indefinitely. So you never get back the result of a workflow, but more like a key that you can use for, and then you can query the state of this workflow. So here a very basic example of an actual workflow. So you inherit from a base type, you specify the input and output, and then you need to override this run async method. And then you use this built-in workflow context to do all kinds of operations within the workflow. So you can call different activities, the smallest building blocks of a workflow. Again, you provided a name and an input, and what you get back is then the result of an activity. And you can pass that result again as an input for yet another activity. So this is an example of chaining of different activities. And finally, an example of a workflow activity. So again, it uses the same structure. So you inherit from a base type, you specify the input and output type, and you need to override this run async method. And here you can use whatever code you want. So in this case, I'm calling out to an LLM, but you can use anything here. Right. Okay, now some details on how this actually works a bit under the covers. So on the left-hand side, we have your application, which uses the Dapr Workflow client to actually schedule a workflow. You have your workflow class definition, and you have like several activity classes typically. Then this is the Dapr sidecar, so your workflow client will be communicating with the Dapr Workflow. And the Dapr Workflow is communicating with both your app, but also to a state store. So what happens when you use the Dapr Workflow client, it sends a signal to the Dapr Workflow engine to schedule a new workflow. The workflow will actually store some information about this workflow and the input to the state store. It returns an instance ID that you can use later on to get some more information about the workflow itself. Then the workflow engine will send some signal back to your application to actually execute your workflow, because your application will actually run the workflow code. And then for each activity in your application, a signal will be sent back to the workflow engine to schedule these activities. And then if the activity is not yet executed, the workflow engine will send a signal back to your application to actually run the activity. The result will be returned to the workflow engine. That result will be persisted again to the state store. And what then happens is the activity result also goes back into your workflow. What happens then is the workflow will not continue straight to the next activity, but the workflow actually replay from the top. So what happens then is for activities which are already executed, the state of that activity will be returned from the state store straight into the workflow. So activities will not be executed twice because the workflow engine knows that activities already have been executed. So this happens in a loop, so that's a replay functionality. And finally, the workflow is complete. That signal is sent to the workflow engine, and the workflow engine will persist the final workflow result in the state store. So there's a lot of communication going on between your application and the Dapr sidecar, the workflow engine, and the state store. So it's important to realize that. But because of all this communication and all the checkpointing, it is a very reliable system. Because if it crashes anywhere, the state is always kept in the state store. So workflows I think really are the GOAT. They're really super reliable. They've been used for like decades already. So if you're not familiar with them, I would definitely say, okay, invest a bit of time in how workflows are working. I created some learnings on Dapr University about workflows. I think it's good information to know, regardless if you use it for Agentic AI or not. Okay, moving on to the next Dapr API that we're using. That is the Conversation API. So the Conversation API is basically like an abstraction across many different LLM providers. So from your application, you can call to a conversation endpoint, or you use one of the client SDKs. I will show you the .NET SDK. And you can call to any of the major LLM providers. So this is a bit of a sample code, how it looks like. So you use a Dapr conversation client in this case, and use the converse async method. So it's a bit verbose, but you basically construct an input there that consists of a system message and a user message with some content. You can also add roles and names, etc. And also some options, which actually gives you back your response. So I will show some more elaborate examples later. But this code doesn't show what's the underlying LLM provider, right? Because that's the whole thing about Dapr. It's an abstraction on top of other things. So you actually can't tell what is the actual underlying LLM here. So the only thing that we see here is that we are using a component, a label or component name called my conversation. And Dapr works with component definitions in YAML files, and that's this thing. So this name here is the same thing that we saw in the source code in the previous slide. And this points to a conversation.openAI component. So if you would run this, it would use OpenAI to actually do the prediction. All right, moving on to actually combining workflows and LLMs, because I think now it gets interesting. So I think combining them is really beneficial because workflow engines have been around for decades. They're super reliable. They provide like a good deterministic control over the activities. They're also like very structured error handling and retries and management of their life cycle. So if you combine it with the flexibility of the LLMs and the reasoning capabilities, I think you have a very good solution then, which for I think many cases is already enough. You don't really need one of these agentic AI frameworks. So this talk is mostly based on a blog post I found on the Anthropic engineering blog. So it mentions we've worked with dozens of teams building LLM agents across industries. Consistently, the most successful implementations use simple composable patterns rather than complex frameworks. Right? So it's really about simplicity and knowing your tools, and then just trying out a shiny new toy and just hoping that it works. So the blog post mentions a couple of patterns. So it's prompt chaining, routing, parallelization, Orchestrator-Workers, Evaluator-Optimizer, and autonomous agents. And I've got demos for all these patterns. And I'm not sure if we can cover all of them, but I think we can do most of them. As you can see, these are all the projects. I'm pretty big fan of Star Trek, so they're all in a Star Trek theme. So you can expect many more Star Trek GIFs. I grew up with the next generation. So I'll be running everything locally. I've got Dapr installed, Dapr CLI. I also have Docker installed. If you install Dapr CLI, you get some Dapr services running in some containers. You also get a Dapr. You can also get a Redis container for the state store. I'm also using the Digrid Dev dashboard. That's probably something you've never heard of, but I'll show that a lot. That's very useful if you're developing Dapr workflows. All my applications are .NET 9 web applications, and I'm running a local Llama server with a Llama 3.2 model. So actually, not even a large language model. It's pretty small. Okay, let me start all of my tools. So first the Llama server. Start my model. All right, and prove that the model is running. Yeah, all right. Start the Digrid dashboard. I'll show that to you soon, how it actually looks like. All right. And for all of the demos I've prepared, I'll be using the same configuration. So I'm using this YAML component that's using Ollama. All right. So let me go to the first example, and that's the prompt chaining one. So it's also the most basic, but also one of the most reliable ones. So it's basically like sequential LLM calls, where the output of one call is the input for the next one. So if you visualize that, it's like this. So this is my input for my workflow. I call an LLM. You typically have some kind of a validation or a quality gate. If it passes, you pass for your next LLM call. Again, you have a quality gate and so on. As you can make this as big or small as you want. So when would you use this? Well, when you have like a big task that can easily decompose into smaller tasks, but like a fixed number of subtasks. So that's important. So yeah, you can use it for like multi-step analysis or like content generation or a translation with some refinement and evaluation, as long as the number of subtasks are actually fixed and you all know them. So some pseudocode, if you want to do this with Dapr Workflow, would look like this. So in case of a translation, we would first call a translate activity. When we make an LLM call, we get back a translation in this step, and we use this as an input for the next one, the refined translation, and we use that output as the input for yet another one to evaluate it. So for the demo, it's called the Spatial Anomaly Analysis System. I just realized it's actually a SaaS now. So it analyzes spatial anomalies detected by the enterprise sensors through a sequential 5-stage process. Well, if you look at the diagram, it looks like this. So we have an input with some spatial anomaly data. We first use an LLM to actually process this data. So this is the first quality gate. If it's valid, then we continue. We classify the anomaly, again using an LLM call. We do some scientific analysis, yet another LLM call, and we do a risk assessment. Again, an LLM call. Then another gate, so is the risk critical? If so, we have like an optional activity to alert the bridge. And finally, we always do this generate recommendation activity as well. All right, starting the project now. So let me show you the code. So this is the program CS file where we do the registration of all of our services. Since I'm also using the Dapr State API here, I'm also adding the Dapr client, but for the demo, it's not really that important. The ones that are important is the Dapr Conversation client. We definitely are using that in most of our activities. I'm specifying a bit of a longer timeout here. It's not really that important for this demo because it's pretty quick. But of course, if you do like a lot of if you have a very large context and needs to do a lot of reasoning, a lot of thinking, then you might run into the 30-second timeout, which is the default. So it's useful to know that you can actually specify a timeout on this conversation client, so you don't run into that. If you're using Dapr Workflow, you need to use this add Dapr Workflow extension method to be able to use the client. In addition, you also need to register your workflows and all your activities. So for the people familiar with durable functions, you don't need to do that in durable functions. You don't need to register all of your individual types, but you need to do this with Dapr. Otherwise, the Dapr sidecar doesn't know that your application has all of these types. So what I have here to start this analysis workflow is I've got an anomaly analyze endpoint here. The Dapr Workflow client is injected, and also the Dapr client is injected. The Dapr client is used to save a bit of state, but we skip over that. It's not really what's important now. But we use the workflow client to schedule a new workflow, and that's the anomaly analysis workflow. In this case, I have created like an instance ID up front. So if you don't provide one, Dapr Workflow will generate one for you and you get it back, but you can also create one yourself as long as you make sure that it's unique. So we schedule it here and we give back the instance ID so we can use it later. If you have a look at the workflow, so this is the anomaly analysis workflow here. I first create a retry policy for my activities. This is optional, so by default your workflows are already like persisted. So if the whole application crashes, your data is safe, and you can spin up a new process, and then the workflow will continue. But what if an activity fails, right? So if you don't configure a retry policy for activities, if an activity fails, then also your workflow will fail, and that might not be desirable, right? So you can optionally also configure these retry policies. So whenever I am calling an activity, I will always use these default retry policies. So the activity will be retried in case it initially fails. And since I'm making a lot of LLM calls, which sometimes have a bit of like unpredictable behavior and doesn't return the exact things that I want, it's actually useful to have this retry policy. So this is the entry point of the actual workflow. It's the run async method. We have this workflow context and we have the input. So this is the first activity, the process sensor data activity. We use the raw sensor data from this input. We also specify the retry policy, and we get back this process data. All right, so and we use this process data first in this quality gate. So do we actually have any process data from this first activity? If we do, then we can continue, and we use it in our classify anomaly activity. We get back an anomaly type, and then we use that as an input for the scientific analysis activity. So then we get an analysis back, and we use that analysis for the risk assessment, which is a combination of both the anomaly type and the scientific analysis. So then we have a risk level. Then we check if the risk level contains some specific string that we're interested in. So if it's critical, then we do this optional activity. And finally, we do this generate recommendation activity. So as you can see, whatever happens in this workflow is mostly calling out to other activities and some if-else statements. So that's like always, and so it's always deterministic. So whatever you need to do in a workflow is never use, like, for instance, like random data. So don't create GUIDs, don't depend on date times, don't make direct calls to other services or to databases. Put those things in activities. And so it also only contains like if-else statements, switches, those kind of things. All right. So this is the first activity that we're calling. I will only show this first one because all of them are structured in the same way. We inherit from this workflow activity. We have a string input and a string output. And in this one, we are using the Dapr Conversation client, so that gets injected here. So we override this run async method, and here we are specifying the conversation options, where we mention this conversation component name. So this is also the name that's in this YAML file. So Dapr will figure out that we are using Olama. Here we are using conversation client with the converse async method, and here is what is actually being sent. So we have a system message, you are Lieutenant Commander's data, sensor analysis subroutine, etc., etc. And then the user message with, okay, process this sensor data, and this is getting fed in with the activity. And this is how you get like data out of the response. It's a bit convoluted at the moment. I think there will be some help methods to make it a bit easier to read. But at the moment, this is it. So let's start the workflow. I'm yet again using another VS Code extension called the REST client. I have this HTTP file, and then you can create all of these requests here, and I can actually execute them here straight in VS Code. So this is the payload that I'll be sending to the anomalies/analyze endpoint. So let's execute this, and then I'll jump over to the Diagrid Dev dashboard. So we make this request, it's accepted, so now the workflow is running. So this is the Diagrid Dev dashboard, and it's very nice because it visualizes your workflow, so you can see like the state of the workflow, the ID, what type it is, when it was started, when it was completed. Well, it's not completed yet, and you can drill down into this workflow. So in this case, it's completed because I already see an output. So this is ideal for like inspecting the workflow state, especially if things are going wrong. You can very easily like expand on these nodes and just see, okay, what was the input for this scientific analysis activity and what was the output for this activity. So this shows the entire execution history. So if I scroll to the bottom, so it's in reversed order. So what happens first is at the bottom, we can see that the execution is started. Then we see the first execution of the activity, the process sensor data activity, which then moves on to the classify activity, scientific analysis, and so on and so on. So yeah, if you're dealing with Dapr Workflow, this is a very nice thing to use. Right, it still says running here, but it's not. Yep, all right, it's done. And it took like 17 seconds, that's pretty okay. So let's actually have a look at the result now. So what's the result? If we scan, look down here, this is all of the individual stages. So the anomaly type is a wormhole, so we have some scientific analysis here, formation theories, we have a risk level high, and then tactical recommendation. I think science fiction is also a great use case for LLMs, because it doesn't really matter what the LLM comes up with. It's always like, okay, sure, yeah, this is fine. Yeah. All right. Let's stop this demo. Right, so prompt chaining, it's really quite easy to understand the flow of this workflow. It's also quite accurate, right, because you can split up a task into subtasks and you can get really like specific prompts for these specific tasks. So I think that works really well. And typically also add these validation gates. So yeah, you have a lot of control when you use this prompt chaining pattern. If you compare it to just making one call, which does everything, of course, yeah, you do like subtasks, so you have multiple calls. It means higher latency because you make multiple calls, and also means like, yeah, you probably have like increased costs as well because you make multiple calls. But I think it's worth it because I think the value, the quality, what comes out of it is better. Okay, the next example is routing. So there you classify input, and based on the classification, you route the request to a specific handler. So that looks like this. You first have an LLM to do the classification, and then based on the classification, you send it to a dedicated handler. And of course, this can be like, you can use like different LLMs here as well, right? So for one, you can use like maybe a large language model. For the other handler, you can use like a small model. Or for the other handler, you can do like, yeah, no LLM at all, right? Maybe you can use some old-fashioned coding. So again, it's quite flexible. When you would use this, well, when really distinct categories are better handled like separately instead of just one thing that handles everything. A very common use case for this is like customer service routing, right? Because different areas for customer service. So here's some pseudocode of how you would do this in Dapr Workflow. So first you would have the classify activity, right, to do the classification itself. And then you have the output of that, and then you can use like basically like an if-else statement or like a switch statement with all of the options. So it's really quite straightforward how to do that. So the demo I have is called the Galactic Anomaly Classifier. So we classify and route different types of space anomalies to specialized analysis activities. So okay, so the diagrams are getting gradually bigger as well over time. So we first do the LLM call to classify the anomaly, and then based on the anomaly type, we have like different handlers. So there's one for temporal rift, there's one for dark matter, alien artifact, stellar phenomena, and dimensional tier. But only one of them will be called, right? So that's important to realize. All right, let's start this. And we only have a look at the workflow now. We don't have to go through the whole program CS file and all the activities, but I think it's nice to look at the workflow. So what we have here is we have the classify anomaly activity, which gives us back the classification, right? So we get back the type of anomaly from this classification. What we have is like a basic switch statement, right? It just checks, okay, are you a temporal rift anomaly? If so, just run the analyze temporal rift activity for this. And we get back the result, and we just extract the right fields from this result. And the same for all of the other ones. There's no real magic. It's quite easy to understand. What is very important, though, is that you, of course, always use a default, because the classification can result in something that you didn't think of at first. But you always need a handler to handle the edge cases. So you'll run into this quite quickly if you don't. I'll skip the activity because it's the same setup as we saw before. Okay, so let's do this temporal rift request. So we actually already know the answer. It should end up being processed as a temporal rift. Let's call this endpoint and let's see what is happening. Okay, so the classification workflow is running. So let's scroll down here so we can see that the workflow is started, the classification is running, so this doesn't live update, so I have to hit refresh a couple of times. Oh, I just promoted someone else's book. It was called Hit Refresh, right? Satya Nadella's book.
Oh, yeah.
Yeah, okay. So, and yeah, indeed, the classification is done here, and we see that the analyze temporal rift activity is indeed called, as it should, so it's good. And here the workflow is indeed completed. So if we inspect the output, we can indeed see that there's a temporal rift classification. This is the result of the specialized analysis. And then the recommendations here. Deploy advanced chronal dampeners to mitigate causality loop effects and protect against tachyon radiation. Brilliant. Yeah. LLMs are great for this. Okay. Right. So let's have a look at the pros and cons for this. Yes. So the pros is you have your specialized handlers per category, right? Which again, it improves the accuracy because you're not doing like a catch-all thing, but you can be very specific for these things. So you can use it as well for like a cost optimization, right? What I mentioned before, maybe for some handlers you want to use like an expensive model. For some other categories you can use like a very simple model, or for some other things you don't need like an LLM interpretation at all. Of course, it's all very dependent on the actual classification, right? So the most important thing is to have the first activity that you're calling. So that's really important. What's also good to realize is if I would really use this in practice, I would route to a completely new workflow. So what you can do with Dapr Workflow, but also other workflow engines, is instead of calling an activity, you can call a child workflow. Because a child workflow can consist of individual activities again. It's very likely that you don't have like one function to handle something, but it again is like a chain of functions. So I think that's the most likely thing that you would do if you want to go this routing area. All right, the next one, parallelization. So here you can execute independent calls concurrently. So let's have a look at this. So you have your input, you break that down into separate pieces, and you can execute all of these subtasks in one go. And the nice thing about it is that the workflow will then wait until all of these tasks have been completed. You can then aggregate the results and give that back as an output. So this exists as like two variations. So one is called like sectioning, and there you actually break that one thing down into smaller tasks. You can also do voting, and then you can actually execute the same task, but then with different inputs, or maybe even with the same input, and then compare all of the results to see if you reach some kind of consensus. So use cases, multi-source analysis, or some kind of a code review step. So here's the pseudocode for doing this. So it's now quite a bit different. So what you see here is that we prepare a list of task of result, and the result is actually the output of all the activities that you're calling. So it's very important that you can only do this when you, if the output type of the activities is the same for all of them. So what happens here is we create a list of all of these activity calls, but you notice that we are not awaiting these individual calls, right? We just are building up a list of tasks that we want to execute later. And that's what's happening here. Here we do await task when all, and then providing all the tasks there. So at that moment, the Dapr Workflow engine will actually schedule all these calls and will actually wait until they've all completed. And then the final step is you probably want to do some kind of aggregation or summary over it. All right, so the demo for this is the Starship Diagnostics one. So it performs like a diagnostics on starships, and it runs like independent scans simultaneously. And then in case of critical findings, it also does a round of voting on different aspects. So this is how it looks like. So the inputs are some Starship criteria or some metrics. Then we start all of these parallel scans. So we do like a hull integrity scan, a reactor core scan, a navigation, life support, and weapons. We combine that in a result. If any of those are deemed critical, then we do a round of voting, and then we have different voting activities for different aspects. So we have an aspect for like safety voter, a severity voter, and a recommendation voter. So that means like a cost-benefit analysis. So once those are completed, we also combine those, and then we combine both sets, so both all of the analysis results and the voting results. So this is quite a bit more involved. So let's run this and have a look at the code. So the parallel diagnostics workflow. So here we go, the run async method. So what comes in is a Starship input. So here you can see that we are preparing that list of task scan results, right? So we are building up this list of all of the activity calls to different activities. And here is the place where they are all scheduled, and the workflow will wait with further execution until all of these activities have been completed. Then we check if any of them have critical findings. And if they do, then we loop over these critical findings, and then we do the same thing, but now for the voting. So we have these 3 different voting activities. We also execute them. Then we aggregate those votes and findings out of it. And then we aggregate both the scan results and the votes. And then we create a final report in this aggregate results activity. All right. I'm skipping over the activity. Okay, let's make this request, and we'll do like an analysis on the user's enterprise, but this telemetry, and it should have like multiple issues. So let's see what it comes back with. All right, it's running. Let's scroll down. So as soon as it started, you already see that all of the specialized things are scheduled like at the same time. So if I now refresh. Some of them are completed, so the life support scan is completed, the weapon scan is completed. We can actually inspect already what it says for the weapon scan. Replace power coupling in phaser array 3, of course, yes, okay. All right, and at this moment it's done, right? So what it did, it completed all of these individual activities. I don't see the recommendation voter activity. So yeah, so it did found a critical one, because otherwise these voter activities wouldn't have triggered. So it did find a critical one, and here it did the aggregation of everything. So let's expand this and have a look. If we scroll down here, there's a lot of output. Okay, so here are the critical votes. So the critical thing was the hull integrity. Apparently they were very unanimous. It needs urgent repair. So we're not clear for departure, and yeah, we need all these required repairs. And it even gave me an estimated on how much time it takes. Wow, amazing. Okay. All right. Okay, let's stop this. Right. So parallelization. I mean, yeah, of course, there's greater throughput. Yeah, go ahead.
I think now for the critical finding
Yeah.
handling, you do that single-threaded, right? Still, you could still do that parallel as well, or not?
At the same time as the others, you mean?
Yes. So I think if you had like a for each loop over the critical findings.
Yeah.
And then for each critical finding, you spawn 3 voters.
Yeah.
But could you
Yeah.
still do the critical findings if you have 5 critical findings spawn?
Yeah, indeed. Yeah, you're correct. Yeah, it could be even more in parallel, indeed, as you mentioned. Yeah, true. Yeah. In this case, so yeah, that's also a good use case to start these child workflows then with their separate sections. So yeah, in this case, I'm keeping it sort of simple in one workflow, but that would be a good use case of putting it in the child workflow. Good point. Yeah. So yeah, pros are indeed high throughput, can be even higher indeed, but also high confidence if you use this voting aspect. The cons is, yeah, you might not be able to use it because you can only use it when tasks can really be like subdivided and be really independent. So yeah, if you don't have like independent tasks, yeah, then you cannot use this approach. All right, next one is Orchestrator-Workers. So now it gets a bit more dynamic. So with Orchestrator-Workers, you first have like an orchestrator LLM that defines what needs to be done. And then it decides, okay, here are the workers that needs to do some work. So the task comes in, that will be broken down in some smaller tasks. But for one request, it might only need this worker, but for other requests, it might need these 2 workers. And for yet another request, it might be all of the workers. You don't know up front, but yeah, things need to be decomposed and handled by workers, but yeah, it might depend from case to case which one you need. So at the end, of course, we gather back all the results from these workers because yeah, you never know which one will be used. And finally, we do some summary again. So when would you use this? Well, when you need some kind of a dynamic decomposition of tasks. So depending on the request that you get, you might need some kind of different decomposition. So it's usually for more complex, slightly unpredictable task structures. And not completely unpredictable because you still need to write all of your workers, right? I mean, it can be completely new. You still need to think of these things, but at least you have like more variations in it. And so you can use it for like coding agents to handle different types of files or different types of languages. Also research tasks, which can be quite different, or complex planning. And that's actually the topic that we're going to do. So some pseudocode how to do this in Dapr Workflow is you would have like a decompose activity where you use an LLM to give you instructions on what you want to do. And here you could iterate over these instructions, and then based on the instructions you have like workers. In this case, this is not very realistic because now the same worker will be started for all the instructions. What will happen is based on the instruction you will have like a different worker and execute that worker. You wait until all of them have been completed, and then you do some consolidation on the output. So what we have here is, as a demo, is the space colony planner. So that's a good example of like a more complex planning tool. So it does dynamic space colony construction planning. So what we do first is there will be like an analysis of a planet conditions. Based on that, there will be different construction work that we want to do on a planet, which requires specialized workers. So the end result is like a colony construction plan. And by the way, this is the only GIF that's not the next generation. This is from the very first original Star Trek. All right. So again, our diagram grows bigger. So the thing, I hope it's still like visible for the people at the end. What we first have is like an activity that analyzes the planet. Then an activity that determines what kind of structures will be required on the planet. And then there's like a dynamic routing happening. So in case we need habitats, then we have a handler for that. If we need a power plant, we have a handler for that. Agriculture, mining, research, and defense system, right? So it really depends on the planet, what kind of structures we need, and which other workers or handlers we then need. The workflow will wait until all of these which are required have been completed. Then we create a construction plan, and then we do a refinement step yet again on the plan. Okay, running this. Okay, so let's have a look at this workflow now, because it's quite a bit different. So first we have the sequential part, analyzing the planet activity. So what we have is the planet analysis, and we use that as an input for the determine structure activity. Then we have the structure requests. So in this case, we do like a for each of the structure requests, and here we have a switch where we just map the whatever key we find here to the corresponding activity. And so if the key finds, if you find habitat dome, then we want to run this activity and so on. And again, it's very important that you have like a default switch as well, right? Because probably there will be some cases that some new or undefined structures will be found by in this case the LLM. So yeah, you always need to make sure that you have kind of an edge case handling for this. So that's why I introduced the unknown structure activity. So all of these tasks are added to the worker tasks, and here we are executing all of them. So for the end result, we have this master plan. All the plans go into that. So then we have the first plan, and then there's an optimization step, which actually splits it out into different phases to help us sort of with the logical ordering of things. I'm skipping over the activity. All right, so let's run this planning for this planet with all this data. Let's go. So this probably takes a bit longer now. Let's have a look, because it first needs to do two sequential things, then it needs to do a lot of things in parallel, and then we end up with a sequence of two things again. So now it's determining the required structures for this planet. I'll hit the refresh again. All right. Okay, so here, so it found quite a bit of things. That's probably everything, right? Ooh, it's interesting. So it also found something that I didn't expect to know. So we also have like an unknown structure activity. Interesting. Power plant, mining, yet another unknown. Interesting. Okay, so now it's synthesizing the plan. And then there was one more step for a refinement. So I'm waiting for that one. Let's see, no. Yes, okay, it's completed. I just have a quick look at what's here because I'm curious what kind of things. Okay, so apparently a shielding facility I did not think of, so that's like an unknown one. Okay. What else is unknown? Well, I think that's the only one. Okay. But it gives us a very nice estimate of 2,550 construction days. Excellent. A whole list of materials required. And then this is the refinement step. So it gives you actually a timeline with phases and what you need to do, etc. So, of course, this is all like completely imaginary, but you can use it like this if you want to colonize your own planet. All right. So the pro of this orchestrator worker pattern is, well, it's very flexible and adaptable, right? I mean, I did not think of a shielding facility to add, but now I've seen it appear, so now I can add my solution with a shielding facility, you know? So it's also very extendable. So that's great. So it can really scale to more complex problems, right? And yeah, each handler can, of course, be very, very dedicated and focused on its own task. Again, if I would make this for real, I wouldn't just do activities to handle this, but I would create like entire child workflows to handle these things. There's also high complexity, but I think it's also like quite manageable, right? I mean, it's still sort of overseeable what it's doing, even though it's more dynamic now. And again, the most important part is the start. It's really the orchestrator which defines what the output is of this dynamic classification. So. Right, let's do one more, the Evaluator-Optimizer. So this is like an iterative loop and to generate things and to evaluate and then do a refinement step in a circular way. So now the diagrams become a bit more basic, but we're actually looping it now. So when you start this, then you first check, okay, is this the first time running? If it's the first time, you run this generator to do some kind of analysis or generation of something, and then you evaluate the output. If it meets your criteria, well, then you're done, but typically that's not what happens. If something is not good enough yet, it doesn't meet your quality threshold. So then you continue. You always need some guardrails. So in this case, since it's iterating and looping, you need to specify some max iterations that you want to do, because otherwise this workflow will never complete. And you also need to pay a lot if you're not running it locally. So then you continue this iteration. And then we are not in our first iteration anymore. So then we do a refinement step of this initial generation part. So we do a small tweak, and then we evaluate again. And then we do the same thing. So we evaluate, do we meet our criteria? No. Max iterations? No. Okay, let's do a loop again. Right, so this can continue if you don't meet your quality criteria until max iterations is reached. So when would you use this? Well, when you think there's value of like doing like small increments and these iterative refinements, you do need very clear like exit criteria, right? So you need to be very specific on, okay, when is something good enough? And also, how far and how long do you want to continue with this? So you can use this for like doing like content quality improvements and also like code generations with like validation and linting. So here's some pseudocode where I first specify some quality threshold that I have, the max iterations that I want to do. I call this generator activity, which gives me some output. I evaluate this thing that I've created. Then I check, is this quality is this good enough, or have I reached my max iterations? If so, I exit. If not, I do an optimization step, and then I instruct the workflow to continue as new. So what's important to realize in your workflow, you never have really a main loop, right? So you don't have a while loop or a do loop in your workflow. If you want to loop your workflow, you instruct it to continue as a new workflow, and that means it forgets its history. You give it some new input, and it starts as a fresh instance. So in this case, there's this alien translator that we're using. And we use it for like a translation refinement, right? So we do an initial translation, we evaluate. If it doesn't meet our criteria, we do a refinement of translation, and then we just keep looping until we have either met our quality standard or we have the max iterations. So the diagram is pretty similar to what I just shown you. We do a translation, We evaluate if it's like if the quality is okay, then we stop. If the quality is not okay, then we haven't reached our max iterations. We continue as a new one. We do a refinement of a translation, and then we just keep looping. All right, so let's start this. So the workflow looks like this now. We have like max iterations. So this is our guardrails. We never do more than 5 iterations. And we have our quality threshold. So the first thing is we do here is, okay, we do a check from, okay, are we already inside an iteration? If not, we do the original one. We do the translate activity one. We have a translation as an output. Otherwise, we call the refined translation one. Then we do the evaluation on the translation. I'm also keeping some checks and balances to also see the incremental changes here. So that's why you see I'm appending things to lists. That's period optional. So this is then the first exit criteria. So if it's like a quality-based thing, if I met quality, okay, then fine, return this output. The other option is, okay, if I reach my max iterations, I didn't meet my quality criteria, so it's like a different kind of output. So that's why it says, okay, manual review still required. And otherwise, I update my input with all the translations and evaluations that I already did, and then I restart the workflow with this continue as new method with this updated input. Okay, I'll skip over the activity. Let's run this. So we'll use this Vulkan diplomatic request that we're going to send. So let's send this, and let's go back to this. So the translation is running. Now I've seen it go multiple ways with the same input. So sometimes it's continued in just the first iteration already, and sometimes it takes like 2 or 3 times. So I'm very curious what happens now. So of course now it's the first time. So this first time we call this translate activity call. And yeah, it's already completed. Yeah? So already after the first evaluation, the quality is already high enough that it stopped. So it actually didn't even loop yet. Let me just do it once more to see if it actually triggers another one. If not, I'll just continue. Oh, is this the new one? Oh, I'm just running the same one now. Okay, I'm using the same ID. I shouldn't have done that. Okay, let's move on to the next. Or actually, no, we don't have time for the final one though. Okay, let's go over the pros and cons, and then I'll close. So, Evaluator-Optimizer, I mean, it's great if you want like small quality improvements. I couldn't demo that, unfortunately, but still, the demo works. Of course, you can have like unpredictable iterations, right? So in this case, I didn't actually, I was sort of keeping track of the score, but yeah, you can have like a lower evaluation on the next round. So in this case, it might actually be worthwhile to also keep the previous one and then figure out, okay, are we going in a good direction or a bad direction? Again, this is looping, so you will have like a higher cost and latency compared to just making one call and hoping for the best. Okay, I will not do the autonomous one. That's, let's say, the least deterministic. But yeah, I will share all the code, so you can run this yourself if you want. Okay, final stuff. So I hope you realize now that agentic systems are distributed systems, right? And we can actually use all of our existing tools. I mean, if you want to use like shiny new toys, please go ahead. But you don't need to use the shiny new toys in order to build agentic systems. Please look into Drupal execution if you didn't do so already. I think workflow systems are really very, very powerful. I'm a big fan of Dapr Workflow. Please try it out. I really like the conversation API that Dapr offers, because I can really easily switch from one LLM provider to another LLM provider without changing code. So it's convenient. And I think it's really useful if you understand these basic agentic patterns, right? Because it's very nice to just mix and match these patterns and see how far you can go without going like all in into like a really agentic framework. So in general, just start simple and add complexity where it's needed. I think in general in IT, I think that's always a good mantra to follow. Okay, you've seen this. I think this is very useful. This is just like a free download. Runs in a container. Super useful. There's also something else, if you really want to run Dapr Workflow in production, Duiker has a tool called Catalyst. It's really like an enterprise platform for workflows and AI agents. It offers like very nice visualizations of your workflow and inputs and outputs and more management of the workflow. So that's definitely a no-brainer if you're into that. And finally, please leave me some feedback, rate the session, and access all of the resources there. So there's links to Dapr University to learn more about Dapr and workflow. There's a link to the original Anthropic post that was the basic of this talk. Also links to like Catalyst and how to run and install the dashboard. And also ways to connect with me. So thanks very much.